Lesson 50, Graphing Inequalities. A linear inequality in one variable can have multiple solutions. So, for example, if I have 3x is less than 7, okay, I just need to find numbers that will go in here for x that will make this less than 7. I can see that 3 and x are being multiplied, so 3 times 1 would get me 3, and 3 is less than 7. So if I put in 1, okay, so I would have 3 is less than 7. Well, that one works, okay. If I put in 2, that looks like a 7. 3 times 2 is 6, and 6 is also less than 7. So you can see that there can be multiple solutions whenever we're dealing with inequalities. On this one, the same thing happens. I want it to be greater than or equal to 10. Well, for it to be equal to 10, x would have to be 12. I just put it in 2, excuse me. Greater than or equal to 10. Okay, so that would give me 10 is greater than or equal to 10, which is true. If I want it to be greater than, okay, it would have to be something bigger. So if I put 13 minus 2 is greater than or equal to 10. 13 minus 2 is 11, and 11 is greater than 10. So both of those are solutions to this. There are lots more than what I just showed you for both of those, but I just wanted to give you an example of what they mean by having multiple solutions. So example 1 says determine which of the values 0, 2, 4, and 6 are part of the solution set for the inequality y minus 4 is greater than or equal to 2. So all you have to do for something like this is that you can just plug and check it out. So if I have 0 minus 4 is greater than or equal to 2, that would give me negative 4 is greater than or equal to 2. And that's not true. So 0 would not be. If I put in 2, 2 minus 4 is greater than or equal to 2. 2 minus 4 is going to give us negative 2, greater than or equal to 2. That's also not true. Negative 2 is not greater than or equal to negative 2. The next one, if I put in 4, 4 minus 4 is greater than or equal to 2. So 4 minus 4 gives me 0. Is 0 greater than or equal to 2? No. So 4 doesn't work either. If I put in 6, 6 minus 4 is greater than or equal to 2. 6 minus 4 is 2. Greater than or equal to 2. It is equal, so 6 would be part of the solution set. Equivalent inequalities have the same solution set. So we can express solution sets by graphs. So for example, if I have x is greater than 0, well, first of all, I always plot by the point that I'm talking about. So I'm talking about 0, so I put a point at 0. Now when I did that, notice that this point is open. It's open because there's no equal to symbol. If there was equal to, I would close it, like on this one. There's an equal to, so this is a filled in dot. Okay? And then I can, as long as my variable is on the left-hand side, I can make an arrow using that symbol, and it tells me which way to shade. So on this one, x is less than or equal to 0. The point that I'm going to plot is at 0, so I put it there. It has the equal, so it's closed, and the variable's on the left-hand side, so I can make it an arrow, and it says to shade to the left. So on these, it just wants us to graph the inequality. And on the first one, they don't give me numbers here, so I'm going to have to make up my own. So I'm going to put 8.0 here, and we'll go 9, 8, 7, 6, 5. This will be 7.5. 7.0. Okay? So I have that W is less than 7.9. Well, first of all, 7.9 is going to be right here next to that 0.8. Okay, and I can label it that way so I know that's what I'm talking about. I don't have an equal to, so I'm going to leave it as an open point. My variable's on the left-hand side, so I'm going to make my arrow, and it says to shade to the left. So I'm going to take my line all the way down my number line. I'm going to fill in right there. So This is representing that W is less than 7.9. On P, P is greater than or equal to 3. So the point I'm talking about is 3, so I'm going to put a point at P. Okay. It has the equal to, so I have to shade that in. Okay. And then my variable's on the left-hand side, so I can make it an arrow, and it says it's pointing to the right. So I'm going to make my arrow to the right and shade that direction. Okay. I want you to try the next two on your own paper, so go ahead and pause at this time so that you can do that. Okay, on C, again I don't have the numbers because I didn't have the right number line for it, so I'm going to put -10, -8, -6, -4, -2, and 0. Okay, so the point that I'm talking about is -8, so I'm going to put a point at -8, and it has the equal to, so I'm going to shade it in. Okay, and my variable's on the left, so I'm going to make it an arrow, and it says that it's pointing to the left. Final answer. On D, this one is a little bit trickier because we don't have the variable on the left-hand side. So I'm going to start by putting it on the left-hand side. So I'm going to put T over here, which means 4 has to be over here. Now the key with this is whenever I flip these two, I also have to flip my sign. So instead of it being a greater than symbol, it's going to be a less than symbol, because now I can read it as T is less than 4 instead of 4 is greater than T, which both mean the same thing, but this is nicer for when we graph. So my point is going to be at 4, and I don't have an equal to, so it's going to be open. My variable is now on the left-hand side, so I'm going to make my arrow. It says it's going to the left, so I'm going to shade to the left. Now it wants us to do the opposite. We're going to write the inequality for each graph. So on A, we can see that this has an open point, or an open point, and it's pointing to the left. So that means it's not going to have an equal, and it's pointing to the left. My variable is going to be here, so I'm just going to call it X. Excuse me, you could call it A if you want to. So I have X is less than, and the point that I'm talking about is -7. I want you to try and do B and C on your own paper. So go ahead and pause, please. Okay, on B, I'm going to say that I'm talking about B this time. And the point that I'm talking about is obviously at 15. It's a closed circle, so I'm going to put the equal to symbol. And it's pointing to the left, so my sign must point to the left. So it's B is less than or equal to 15. Final answer. On C, same thing here. I'm going to say we're talking about C. And we're talking about the point that this is at, which is 2/3. It's an open point, so there's no equal to. And it's pointing to the right, so it's going to be pointing to the right, which means greater than. So I have C is greater than 2/3. Okay. The temperature on a winter day is no more than 40 degrees. The temperature is no more than 40 degrees Fahrenheit. Write an inequality showing the possible temperatures on that winter day. So the temperature, I'm going to call it T. And I know that I'm talking about 40 degrees Fahrenheit. Okay? I know that it is no more. Can it be 40 degrees? Yes. And if because it says no more, it could be 40, but it can't be more than 40. So I'm going to put my equal to, because I know that it can be 40. It cannot be more than 40, which means it cannot be greater than 40. So if it can't be greater than 40, it must be less than 40. So T, or the temperature, has to be less than or equal to 40 degrees Fahrenheit. Graph the solution set of the inequality. I'm just going to show, we'll see, 38, 39, 40, 41, 42. And the point that I'm talking about is at 40. I'm going to make my point. I see it has the equal to, so I'm going to shade it in. Okay, and it's pointing my arrow to the left. My arrow goes to the left, and I shade that direction. Final answer, that's all I have for you. I hope that you have a good night.